Hello everyone. This is a demo for our group project, which is a Wordle solver. So basically, we have implemented 4 different algorithms that you can play interactively, and it's built on a application, a web application. So let me run the server real quick. Okay, so let's click F5 to see the loading screen again. All right, so the loading screen, it loads up the user interface as well as some backends. So all right, let's talk about the user interface. So first of all, we have the title for the web. We have a toolbar. So we can change the theme. We can pause the game in case you're playing in AI mode. We can restart, move to the next step. All right, the main component of the game is the game board. So you can type in a word to guess, as in a Wordle, a normal Wordle. So you can also type with the virtual keyboard in case your physical keyboard has some problems, but you cannot type to more than 5 letters. So we have a statistic table. So it's gonna tell you the number of attempts, the remaining words, and the current solver. We also have an algorithm visualization, so you can see the charts that explain the statistics. But right now they're empty since I haven't played anything yet. All right, so move on to the algorithms. We have 4 different algorithms, and you can choose any of them to start playing the game. And when you play, you can choose to play in hint mode or auto. So hint mode, they're gonna suggest you the words that are most suitable in terms of the logic of the current solver. So these words are ranked from best to worst in terms of how probable it is according to the logic of DFS. So to know more about how the algorithms work, you should read the report to see the logic behind it. So right now I can click on one of the words to play. Okay. And as soon as I click on one of the words, it's gonna tell me the statistic of the words that I have just played. So I've received a feedback about the number of correct letters, the number of misplaced letters, and from that the solver is going to deduce the remaining words that can be the secret words. So this is the word space reduction chart. And we can also see that the proportion of words that have been eliminated. So we have eliminated 99.7% of the words. So from 13,000 comes down to only 38. So maybe I can type in a word manually here. All right, cool. So we have 14 words left. Um, maybe try typing with the keyboard. Okay, 12, so I didn't get lucky there. All right, I seem to not really lucky, so it was awake, and when I fail a game, it's gonna be game over, and it's gonna notify me. So you can choose to play with an AI as well, so it's gonna play for you according to the same logic. Okay, right. So when you win the game, it's gonna announce that we have found a word within some attempts. So I found SWAT in 5 attempts. Right. So let's move on to a different solver. So knowledge base hill climbing. So this algorithm is a local search algorithm that use a heuristic on each character. So basically, the heuristic use is the frequency of each character with respect to the currently remaining words. So this value here is the heuristic, and since it's a local search, we only choose the most probable word here, only one, to appear in the suggestion table. So I'm going to play the words. So as I play, the statistics are updated. Okay. Right. We have 6 words remaining. And if I get lucky, no, I didn't. Right. So maybe ask the AI to play it. And when the AI play, you can pause the game and you can resume at any time. Okay, so we have found the words in 3 attempts. So let's move on to the next solver, which is our most optimal solver, which is the full entropy solver. So this one, it uses the concept of entropy to suggest words. So basically, for each word, you're going to compute the entropy of the feedback distribution. Um, so the higher the entropy, the higher the uncertainty. And a big value of entropy means that you are likely, it's expected that you're going to prune out a lot of words after you play this word. So I have pruned down like 10,000 words, which is very large. And that expected amount is approximately larger. It is expectedly larger than those with small value of entropy. So the ones with the large entropy are listed first. So to see more about the logic, you can visit the report. Okay, so okay, maybe in AI mode as well. So it takes a little longer, but entropy is the most optimal algorithm that we have. So it is very likely that it's gonna solve it anytime. So moving on to progressive entropy. This one is a stochastic version of full entropy. So it's gonna be quicker, but it's just gonna sample a bunch of words, but not computing all of the words, all of the entropy of each word. So let's try to play the word. All right, so you can see here, this is also entropy of each word of the distribution. So when you click on them, you can see that the words are pruned out a lot as well. So yeah, maybe we can let the AI to play it. Okay, we have found the word curse in 3 attempts. So basically that's all the main things about this application, and thank you for watching the demo.